So today the goal is to tell the difference between a numerical expression and an algebraic expression, as well as taking one and writing it out using keywords. So let's follow these, do these notes with me. Make sure everything I fill in, you fill in with me. An expression with only numbers and operations is called a numerical expression. Here's how I remember this. An expression, remember, that's kind of like a fancy word for a math problem. So it's a math problem that only has numbers. How I remember that is numerical starts with NUM, and so does the word number. So basically a numerical expression is a math problem that only has numbers in it. So an example could be 5 times 2 or 8 plus 9 times 3. So I want you to write an example of a numerical expression. So just a regular math problem with numbers. Okay? An algebraic expression, which we talked about before, an algebraic expression is an expression that contains numbers and variables, or just variables by themselves. So remember, I always underline AL because algebraic and alphabet both start with A and L. So the algebraic ones are the ones that have variables in them, which are usually letters. So an example could be 6 times B or C minus K. The main difference between an algebraic expression and a numerical expression is that algebraic contains variables, or you could even put letters, and numerical does not. So numerical only has numbers, so numerical numbers, that's how I remember it. To write an expression, use keywords to determine which operation to write. So below I put a chart with some keywords to help you out, so ones that imply addition, subtraction, multiplication, and division. Okay, so we'll flip this over. So we are going to practice taking a phrase and writing it as either a numerical or an algebraic expression. So for example, the sum of 7 and 3. The key word is sum, which means to add, if you look at the chart. So the expression would be 7 plus 3. So you're taking the phrase and you're writing it out as a math problem. And this is a numerical expression because it only has numbers. Okay, let's try another one. For example, the difference of Q and 4 has the keyword difference. Oh, I already typed that in. So the keyword is difference, which means to subtract. You can use the chart if you didn't know that. So the answer is Q minus 4. This is an algebraic expression because it is a math problem that has a letter in it. So if it's a math problem that has a letter in it, it's called an algebraic expression. If it's a math problem that only has numbers, it's numerical. Okay, so I'm going to have you try some practice problems below. First one, I want you to just watch, and then I'll give you a few to try. So this first one says 8 fewer than 21. So fewer than is our key phrase, which means to subtract. But with subtraction, the order matters. So you have to read it really carefully. 8 fewer than 21 means you're taking away 8. So 21 take away or minus 8. And this is a numerical expression because it only has numbers. Okay, the second one says the product of 30 and 9. Product is the key word. That means multiplication. So 30 times 9. This is also numerical because it only has numbers. Okay, so I want you to pause and try these two. So you're going to write out what the math problem looks like, and then I want you to tell me whether it is numerical or algebraic. Okay, let's try these. I'm going to do these ones. You can just watch, and then I'll give you some to try. So let's write the phrase as an expression. 14 more than a number x. More than means add. So 14 more than x means x plus 14. Since this has a variable or a letter, this is an algebraic expression, which again just means a math problem that has letters in it. Next one says a number y minus 75 is going to be written exactly how it sounds. Y minus 75. This one has a variable, so we're going to call it algebraic. If it has at least one letter, it's algebraic. The quotient of 3 and a number z. Quotient means division. So 3 divided by z. Also going to be algebraic because it has at least one letter. Okay, so I'm going to give you some of these to try. So I'm going to have you try all of these ones. You do not have to write out the phrase. You're just writing the final answer. So look for your keywords, figure out what operation it is, and then I want you to also tell me whether it's algebraic or numerical. So pause and try all of these ones. Okay, now we're going to apply this type of logic to a word problem. It says the length of Interstate 90 from the west coast to the east coast is 153.5 miles, more than 2 times the length of Interstate 15 from Southern California to northern Montana. Let M be the length of Interstate 15. Which expression can you use to represent the length of Interstate 90? This is a lot of work here, but the main part we're looking at is right here. 153.5 miles, more than 2 times the length of Interstate 15. They're telling us to let M be the length of Interstate 15. So this entire part here is going to be the letter M. Okay, so now we have to figure out how we would word this. So 153.5 miles, more than means plus, 2 times M. So we're looking for which one has 2 times M, adding 153.5 to it. So that would be answer A. Okay, let's try this one. I want you to do this one with me. It says the number of students in the science club is 4 more than twice the number of students in the math club. Let M be the number of students in the math club. So that means this whole number of students in the math club, this entire section here becomes the letter M, because that's what it's telling us. Let M be the number of students in the math club. So this whole thing is M. So now we have to figure out what would look like 4 more than twice M. Twice M means 2 times M. So 2 times M is twice M. 4 more than that means plus 4. So that would be our expression. 2 times M plus 4. Okay. This one is written very tiny for some reason. Let's see if I can zoom in a little bit. Okay. So as you plant a cypress tree that is 10 inches tall, each year its height increases by 15 inches. Make a table that shows the height of the tree for 4 years. Then write an expression for the height after T years. What is the height after 9 years? All right, so let's take a look. We're going to make a chart. And I'm going to put the year. So I'll put a Y for year and an H for height. So when you first bought the tree, so year 0, you haven't even had it for a year. You literally just bought it. It's 10 inches tall. So I put 0 years have gone by. It's 10 inches tall because you just bought it. Okay, it says each year its height increases by 15 inches. So now we're at 1 year. It grew 15 inches, so 10 plus 15, which means it's now 25 inches tall. I know we could do that math in their head, but the reason I'm writing it will make sense in a second. So now I'm at year 2. So it was originally 10 inches when I bought it, plus 15 inches from year 1, plus another 15 inches for year 2. Now we're at 40 inches. Okay, now 3 years have gone by. It's the original 10 from when you bought it, plus 15 from year 1, plus 15 from year 2, plus 15 for now year 3. So now we are at 55 inches. Now they want us to figure out the 4th year. So 10 from when I first bought it, plus 15 from the first year, 15 from the second year, 15 from the third year, plus 15 from the 4th year, which is going to give us 30, 60, 70 inches. Okay, they want us to come up with what is the general rule. So what are we doing every time? So they want us to figure out T amount of years. So we're going to write a general rule here. So it looks like every column is starting with a 10 and a plus sign. And what would be the same thing as adding 15 a bunch of times? Multiplying by 15. If you notice, for year 4, we have 4 15s. For year 3, we have 3 15s. For year 2, we have 2 15s. For year 1, we have 1 15. So it's 15 times whatever many years you're talking about. So we'll put T for the general rule. So the general rule is the amount of years times 15 plus the 10 it originally was. So if we want to figure out how tall it will be in 9 years, we would do 10 plus 15 times 9, which we would do order of operations. So we would do 9 times 15. So that is 135 plus 10. So in 9 years, it would be 145 inches tall. Okay, so I wrote out all of the work just to help us discover what the rule was. We're repeatedly adding 15, which is the same thing as multiplying by 15. And we're adding 10 because that's what originally it was when we first bought the plant. Okay, so I'm going to have you guys see if you could figure out this one. That'll be your last one. Try to do the chart the same way I just did for this one.